Hi guys, so in this video, we will be discussing the different types of load and the different load combinations that our structures may support. Okay, so first things first, these loads could be classified into three different categories. So the first one is your dead loads. So your dead loads comprises of the weight of the structure itself and the permanent materials or objects that are in our structures, in or on our structures. And then the second category is our live loads. So our live loads could either be movable or moving loads depending on the use of the structure. So for example, our structure is a bridge. So the live loads that will be imposed on that bridge would be your truck loads. For example, we have a building. So the live loads that will be imposed on that building would depend on the occupancy or the use of the building. So if it is used as a school or as a residential building, it would have different intensities and combinations of your live loads. The third category is your environmental loads. So the environmental loads are due to environmental effects. This could be from your wind, from your rain, from your earthquake, and other sources. Now that we know the different categories of our loading, the next thing that we need to know is how are we going to figure out which one of these loads are we going to impose on our building or on our structure, and what are their intensities. So we get those from two sources. So the first one is your general building codes. This specify the requirements of governmental bodies for minimum design loads on structures and minimum standards of construction. The second one is your design codes. This provides detailed technical standards and are used to establish the requirements for structural design. We have here table 1-1 that provides some examples of your general building codes and your design codes. In the United States of America, their general building codes can come from the minimum design loads for buildings and other structures from ASCE, American Society of Civil Engineers, and the International Building Code. For us here in the Philippines, what we use is coming from, or the general building code that we use is from the National Building Code of the Philippines. And then next we have your design codes. So this can come from Building Code Requirements of Reinforced Concrete by ACI, the Manual of Steel Construction, from American Institute of Steel Construction, the Standard Specification for Highway Bridges, and then we have the National Design Specification for Wood Construction, and then the Manual for Railway Engineering. Here in the Philippines, our design codes usually come from the National Structural Code of the Philippines. Now, although this would provide us your minimum standards, your minimum requirements, this will only serve as your guidelines. It is important to note that the ultimate responsibility for the ultimate responsibility for the design lies on the structural engineer. Okay, so next let's discuss the different types of loads that we would place upon or that we need to consider for our structures. Okay, so the first one is your dead loads, as we have discussed earlier. This composes of the weight of the structural members or its self-weight, and then the permanent objects or materials that are in or on our structure. And then second type is our live loads. So, as we have stated earlier, these are usually movable or moving loads. So these are variable loads caused by the use of the structure. As I said earlier, this could depend on the use of the structure, or if it's a building, which would usually be the case in structural analysis in our course. This could depend on the occupancy. So depends on how the structure is being used. Is it an office? Is it a school? Is it a residential building? Is it a parking building? So those kind of things would determine the intensity of the live load that we need to consider, right? For building live loads, these are usually uniform loads as I said earlier, it depends on the type of the occupancy. And then we also need to consider some additional concentrated loads. For highway bridge loads, what we're going to consider as live loads is your truck loadings, as an example, like this one. And then for railroad bridge loads, we're going to consider train loadings. The third type is your impact loads. So, moving vehicles may bounce and impart an impact on the deck of your bridge. And we also consider impact loads when designing elevator machineries. The fourth type is your wind loads. So this effect depends on the density and velocity of the air, angle of incidence of the wind, shape and stiffness of the structure, and then the roughness of our surface. An example of this one is in this figure. We also have your snow and rain loads. So each proportion of a roof shall be designed to sustain the load of snow or rainwater that will accumulate on it if the drainage is blocked. In our case here in the Philippines, we don't usually encounter snow, so we only consider rain loads. The sixth type is your earthquake loads. So from the structure's distortion caused by ground motion and lateral resistance of the structure, design seismic resistant structures to safeguard against major structural damage, maintain functionality after severe earthquake. So earthquake loads are very important in our structural design. So this usually causes one of the most major damages that a structure may experience throughout its lifetime. So one of the most critical loads that we have when we do structural analysis is in earthquake loads. The seventh type is our hydrostatic and soil pressure. So we consider this when the structures are used to retain water or soil or other granular materials. An example of this one is I think this one is a retaining wall. All right. So our next topic would be the different load combinations. So we can have two approaches to our structural design. The first one is your allowable stress design, or your ASD. In this method, this includes both the material and load uncertainties into a single factor of safety. And then the second type is your load resistance factor design, or LRFD. This is also sometimes called as your strength design. In this method, it separates the material uncertainty from your load uncertainty. So, the formulas that you can see here are the different load combinations that we must consider when designing our structures. Right. So when we do our structural analysis, we usually consider different load combinations. As an example, here in ASD method, so we have D plus F. Your D is your dead load, and your F is load due to fluids with well-defined pressures and maximum heights. And then here we have your dead load, and then your load due to lateral pressure of soil and water in soil. And then we have load due to fluids, and then we have your live loads, and then we have your self-straining force and effects arising from construction or expansion. So when we do our structural design, we must ensure that the structure itself and the different portions and the different structural elements shall resist the most critical effects that results from the following load combinations. So it's either we're using ASD method or we're using LRFD method. All right, so that's it for our loads on structures. I'll see you guys on the next video. So thank you for watching.